All right, now you've got a bunch of practice like that, and you'll probably have some questions on that. I'm not pretending to do this comprehensively. I'm just trying to give you the outline of it. There are going to be some details and some difficulties in these exercises. I've designed these exercises so they give you practice at these properties. Now I want to do one more thing, and that's in section 4.04. I want to give you a couple of problems to answer the question that's just probably eating you alive right now. What good is all of this stuff? What good is all this stuff? Well, first of all, logarithms, the great power of logarithms as they were originally conceived by John Napier, was to simplify computation. What it does, it converts a product of numbers. It allows you to calculate products by adding numbers together. It allows you to take exponents and convert them into products. You probably don't understand what I'm saying right now, but let me give you an example of a problem that we need to solve. Let's say you have 2 to the x is equal to 10. Solving 2 to the x equals 10. You have no idea how to solve for x where x is an exponent, right? Now, there are some problems you could solve where x is an exponent. I can show you how to do that. Let me give you a simpler problem, one that you would be able to solve just from your knowledge of numbers and of exponents. And that number would be number 2 on page 29. For right now, it's page 20. The first page, number 2, in the first page on 4.04. On 4.04, the first page, number 2, you've got a problem that says 8 to the x is equal to 4 raised to the x minus 2. Now, believe it or not, you do know how to solve this one. Can you take that 8 and write it as a power? What is 8? 2 to the cubed, right? 2 cubed raised to the what? X equals 2. Now, what's this for? 2 squared, all right? 2 squared raised to the what? X minus 2, okay? So now, if you multiply exponents, what do you have? 2 is the base number raised to the what? 3x. And you've got this equal to, this base number is 2, and what is it? Multiply exponents, so that would be what? 2x minus, I should have used pink chalk, 2x minus 4. Okay? 2x minus 4. Now, can you see you've got 2 to a power and 2 to a power? So what do you have to do to solve for x? All right, just say this power right here, you just say this power right here, 3x, is equal to this power right here, which is 2x minus 4, and then you solve for x. See, and therefore x equals to negative 4. Okay? Now, there's only one problem with this problem, and that is that I have to admit that it is a contrived problem. That is, I made it up so it would work this way. And your average run-of-the-mill problem that just comes up in everyday life is not going to be rigged, so it comes out like that. I fixed that problem to make it work out that way. I did it on purpose. I work hard to make problems come out even, and that's one of them. But now I got a problem right here that you can't do by that method. So let's introduce a strategy that would allow you to calculate the value of x using logarithms. The trick is this. You take the log of both sides. When you want to solve an exponential equation, an equation with variables and the exponents, what I do, I take the ln of both sides. So let's go to 2 to the x equals 10. And let me write that problem down just like it is. 2 to the x equals 10. Now, what I want to do to this equation, I want to take the ln of both sides. The ln of both sides. And what would you get? Now, do you remember the property about log of 2 to the power? That holds for ln, doesn't it? Because ln is a logarithm. So what can we do with the ln of 2 to the x? Do you remember when you have a power? We can take that x and drop it down there, can't we? Call it what? X times the ln of 2 is equal to the ln of 10. Okay? Now, do you see what we did in that one step? Watch this. This is neat. You had an x as a power, didn't you? As an exponent in the equation. And when you take the log of both sides, what happens is it becomes a coefficient. Can you see that the ln of 2 is just a number? The ln of 2 is just a number. And it's x times a number, right? X times a number. It's not an exponent equation anymore, is it? It's a regular linear equation. And the ln of 10 is a number. So what would you have to do if you've got x times a number equal to another number? What would you have to do to find x? Divide both sides by the ln of 2, right? Divide both sides by the ln of 2. Now tell me, what does x equal? X equals the ln of 10 divided by the ln of 2. Can you calculate that? Let's try it. No. It's not the ln of 5. You'll have to calculate the ln of 10. Get your calculators out. Let's do this. It'll be ln of 10. This is the first time you've done this. You'll have to enter ln of 10. And then what? Divided by ln of 2 execute equals 3.32. That looks right to me. Now, why would I say that looks right to me? How could I tell that looks right? I don't have a calculator in my hand.
Right.
I looked at this problem, I said 2 to the x equals 10. 2 to the what is it that we know? 2 to the, this near the neighborhood of 10.
3.
2 to the 3 is 8. Okay, so I know it's going to be a little bit more than 3. So when you said 3 point something, I said, that sounds good to me. Alright, so you get 3.32. You see, well, in order to solve for x in an exponent, taking the log of both sides converts the problem from an exponential equation to a linear equation that you can just solve for x. And that's it. I'll tell you what, let's try that same problem. Pretend you don't know the answer. Well, let's keep the problem right there where it is. Let's do that one using logarithms where we know what the answer is.
So, Dr. Beckley, if I took 2 raised to the 3.32 power.
Right. Try it. Try 2 raised to the whatever that power is. Okay.
32 power equals.
Now that's not the exact value.
9.9866.
Okay, now it came out 9. What happened to it? Why didn't it come out exactly even? Why didn't it come out 10?
Thirds never do.
Because you rounded it off. See, this is not the exact value of it.
If I'd have left that
If you'd have left the...
and raised it, if I'd have taken 2 and raised it to the exact
That's right.
power, it would have came back to 2.
That's right. If you...
proves whether you're right or wrong.
That's right. If you
So
wanted
you
to...
think that is what?
You take this number to the full accuracy of the calculator, whatever it is there, and take 2 to that power. Then you'll get either 10 or 0.9999999. Okay?
2.
All right. All right. I think this is going to be my last problem of the day. I want to try this same problem, only doing it by the method of logarithms instead of doing it that way. Do you agree with me that's probably the best way to do it? If it's a contrived problem, if it comes out 2 to a power and 2 to a power, but you agree with me that that's not going to happen all the time. Like if it comes out 2 to a power equals 3 to a power, then what are you going to do? You're going to have to take the log of both sides. So if I wanted to, I could take that original problem, 8 to the x equals 4 raised to the x minus 2, and I can take the ln of both sides. So here it's going to be the ln of both sides. All right, now what can you do with the power here that gets the power converted over to a linear problem? X, all right? We'll take that x, Take that x and it becomes x times the ln of 8, right? Equals to what? Now this power is a little more complicated, isn't it? So we'll have to do this quantity. Now it's going to be x minus 2, the quantity, times the ln of 4. Whoops. Okay? Times the ln of 4. Right? You see what I did here? I have to take that whole power, that whole quantity, down times the ln of 4. Now the ln of 4 is just a number, isn't it? It's just a number. The ln of 8 is just a number. So if you want to solve for x, what we need to do is use the distributive property over here. Can we do that? Right? That would equal what? X times the ln of 4, and then what? Minus 2 times the ln of 4, right? Like that? Oh, I didn't mean to erase that. Don't erase that. Sorry. We already know the answer. What's the answer going to be? X equals negative 4. That's what I need to keep. I need to keep the answer to this problem because I hope the answer comes out negative 4. I hope. Now what about the other side over here? I've got x times the ln of 8. All right? Now what are you going to have to do if you want to solve for x? Whoa, wait a minute. Wait, this problem's a little different than that one. We got x's all over the place. See all the x's here?
Wait a minute. I don't know how you got that second x.
No, I got what?
That one right
This, I took x times the ln of 4.
there.
See, this is a binomial, so I have to do ln of 4 times the x, and I have to do negative 2 times the ln of 4.
Oh.
Really, this was like the distributive property. The distributive property from the right side. I got x times the ln of 4 and negative 2 times the ln of 4. Glad you slowed me down on that one. I didn't mean to race by it so fast.
I guess you have to move the
Right.
x ln of 4 to your left.
Right. Now I got to get all the x's on one side. So what we might want to do is subtract the x ln of 4 term from both sides, right? That way you'll end up with all the x's over here on this side. Okay? Now that's going to be, I'll have x ln of 8. And what I've done here, I've subtracted x ln of 4 from both sides. Okay, so this subtracts out. And I'll have x ln of 8 minus x ln of 4 equals to, and the only thing left on the right side is negative 2 ln of 4. Okay, now what do we have to do? If you got x's in more than one place, you need to get the x's in one place, don't you?
So you just subtract 4 from A.
What do we do here? When
I
you've
thought you
got,
subtracted the entire thing. The negative x ln 4 from x.
You done?
Yeah.
Don't you?
now I got x times this and then x times that.
Yeah.
Oh,
yeah,
I thought you just subtracted it out. Here.
No, I don't subtract out the x's.
A negative
Why
x
not?
ln.
I got to factor out the x, don't I? Remember factoring out the x? So let's factor out the x, and what's left when you factor out the x? ln of 8, and then minus the ln of 4, right?
Alright, so.
Equals to negative 2 ln of 4. Now what are you going to have to do to solve for x? Divide both sides. Divide both sides by this quantity, right? Divide both sides by the quantity of the ln of 8 minus the ln of 4. Divide both sides by the ln of 8 minus the ln of 4. Okay? Now, all you have to do is just calculate that with your calculator. That's going to be fun. Okay? How would you go about calculating that? The answer is supposed to be negative 4. Let's remember that. It was negative 4 when we worked it out the other way, so it should be negative 4 here. if you have a regular calculator, how are we going to enter this problem here?
We just do the top piece first.
We can just do the numerator part first. Let's start with the numerator part, and let's do 2 ln of 4. Can you do 2 ln of 4? That would be 2 times the ln of 4. Okay.
4 ln is the way you put it.
4 ln, I'm sorry. It depends upon what calculator you use. I suddenly slipped forward into my graphics calculator. So it'll be 4 ln, okay?
Equals 1.38, blah, 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 blah.
All right, now that equals
1.38.
1.38. That sounds good so far, okay? Now, before you go on, we'll have to say divided by. Now we'll have to open parentheses, okay? Open the parentheses, and then do 8 ln minus 4 ln, okay? And then you probably will do close the parentheses and equals.
And I got 693.
Do you get 4?
4.
4. And remember, we still got a negative out in front. So if you get 4 for all of this, then the answer is negative 4. So don't forget that negative out in front. The answer is negative 4. Okay, yes?
That is 2 times 4 ln equals negative 2.77 divided by
2.77?
divided by 0.6.
Oh, it's not that. Okay.
She didn't hit the equals.
Oh, okay.
2.
All right. Whatever you got up here, it seemed to have worked out for you.
Minus 2.77.
Okay. So what was this? This was
Negative 2.77.
negative 2.77.
Don't you up it?
Did you have the negative in it already?
I'll put a plus or minus.
Not sure.
Left to up it. How come it's 2 times 4? That's what I don't understand.
Well, because I did the 2, I didn't worry about the negative. I just said 2.
Yeah,
And if you put in negative 2, that'll give the. I probably should have said that. I probably should have had you do it. Negative 2 times the. You can start with 2 and then plus or minus gets the negative in there, and then times the 4 ln. And then you have to go equals to get the total of the numerator, okay? And then divided by, and then open up parentheses, and then 8 ln minus 4 ln, close the parentheses equals. I'll tell you what's the shortcut though, that I found out about. If you just go minus 4 ln, and forget about that closing the parentheses, instead of closing the parentheses, just say equals, it goes right to the answer. It does.
Say that again.
If you calculate the parentheses open, 8 ln minus 4 ln, and then instead of closing the parentheses, just say equals, then it calculates the whole thing. And it gives you just the answer of negative 4. Or 4, depending upon whether you put the negative into it or not.
Minus 4 ln.
Yeah.
If you put 8 ln and minus 4 ln, is that what you're saying?
What?
Why not do it?
You still have to divide it by 2.77.
Yeah, you still have to divide. Well, see, I've already got this. This numerator is already in there. The numerator is already in there. Then you just do divided by, and then this is what you're dividing by. Ln of 8 minus the ln of 4. Okay? And it comes out right, doesn't it? Let me show you one more quick shortcut on that, and then I'm going to shut this thing off for today. Ln of 8 minus the ln of 4. Do we have a property for the ln of 8 minus the ln of 4? This is not for the faint of heart, by the way. You can, if it's a ln minus an ln, you can make that the ln of a quotient, can't you?
After we put the
I'm not
8
gonna do that.
ln,
I'm
do
not
we
gonna-
multiply times the negative?
Well, yeah, you have to multiply times the negative. If you don't already have that negative in there, you've got to put it in there.
If I was putting it
What?
in the calculator, I'd put 8ln
Minus 4ln.
You don't do it.
So there, we just got into the first real application of logarithms, and that is to solve an exponential equation. And that's what this next section is all about. So in section 4.04, what I'd like to do is a couple of problems involving exponential equations, and then maybe I'll do a couple of them involving logarithmic equations. All right, let's take a look at, for a problem number 18. Number 18, it says 7 to the 2x minus 5 equals 10 raised to the x plus 4. Okay? Now, the problem is a number to a power and a number to a power. So what I want to do is bring this down from an exponential equation into a logarithmic equation. And I can do that by taking the ln of both sides, or by taking the log base 10 of both sides. So what I want to do is take the ln of both sides. So that would mean I need to take the ln of 7 to the 2x minus 5 power equals to what? The ln of 10 raised to the x plus 4 power. In other words, I just took the ln of both sides. Right, now what I have to do is take this exponent, ln of 7 to the power, and do what with that power? Bring it down and make it the coefficient. So what it says is 2x minus 5, the quantity, times the ln of 7 is equal to, and what do I do with this power? X plus 4 times the ln of 10. Okay? Now you see what we have here, this is just a number. ln of 7, ln of 10, they're just numbers. Oh, hey, I just thought of something I want to mention here. If you had used the log base 10 of both sides, then log base 10 of 10 would have just been 1. That would have been a little bit easier to calculate for whatever it's worth. I still want to do it ln of both sides because I think that's generally the best way to do a problem. But in this case, log base 10 might have been easier on the calculations. All right, now what do we do if you've got x's over here and x's over there? We need to distribute this. ln of 7 is just a number, so distribute it. What would that be? 2x times the ln of 7. Okay? And then minus 5 times the ln of 7 equals to ln of 10 times x. All right, x times the ln of 10. X times the ln of 10, and then plus 4 times the ln of 10. Okay? And now, before you can factor, there's one more step you've got to do. You've got x's all over the place, don't you? Let's get all the x's on one side. That means let's subtract x. You get another color. Subtract x ln of 10 from both sides. And in other words, now that's not going to subtract. We're going to have to write it down here, negative x ln of 10. And then you'll end up with, on this side of the equation, what will you have? 2x ln of 7 minus x ln of 10, right? X ln of 10. Okay? In fact, do we need to show that step? Is that helpful or does that detract from it?
No.
Okay. Now go ahead and do it then. All right. Now, if that will, this way, this term will subtract out on the right side. So you've got all the x's on the left side now, right? Now, what else do we need to do? Take all the number terms over to the right side. So I'll need to add what? 5 ln of 7 to both sides. So we'll plus 5 ln of 7 to both sides. All right? I'm just drawing that line over there to kind of separate the problem from what I want to end up with, okay? Equals 2, equals 2. Now, what's left on the right side? 5 ln of 7, all right? 5, let's start with 4 ln of 10. I don't think it matters which one you put first, does it? 4 ln of 10, and then we'll add to that plus 5 ln of 7. There, isn't that pretty? Okay. Now, we still got x's all over the place, so what should we do? X here, x there.
Yeah, but the elements are different, so you can't just subtract them.
No, they're not like terms, so you can't subtract them. What you'll have to do is factor out the x. Remember that trick? Factor out the x. All right, so let's factor out the x, and I'll start up at the top of the board with this. X times, now this is going to be what's left on the left side. After you factor out the x, what's left? You took out the x, so what's left? 2 ln of 7, and then minus ln of 10. Okay, minus ln of 10. Okay, and what that equals is 4 ln of 10. 4 times the ln of 10, ln of 10, and then what? Plus 5 times the ln of 7, right? Okay? Now what? What do you do to get x all by itself?
We divide that out.
Divide this factor, divide both sides by that factor. So that would be x equals 2. Now the numerator factor would be 4 ln of 10 plus 5 ln of 7 over 2 ln of 7 minus the ln of 10. Okay, now, the big question, can you calculate this?
Yes.
Now back in the old days, back in the days when I was in school, we would just leave the answer like that. That's all we could do. You know, without a slide rule or something, that's all you could do. So in math, we didn't particularly care about calculating the exact value or the approximate value of this. But nowadays with calculators, it's easy to calculate this, so we just go ahead and calculate it. What'd you do? 4 ln. This is a calculation problem now. Let's see what would you do first. Let's start with the 4 times 10 ln. 10 ln. Unless you have a graphics calculator. Now, if you have a graphics calculator, you're just pretty much going to enter it like it is. And then 4 times 10 ln. Then we'll do plus 5 times 7 ln. And then you'll have to do an equals to calculate the numerator. Equals, that should give you the numerator. Okay? 11.18. Uh-oh. Anybody want to break the tie?
Maybe I entered it wrong. I should have put 10 ln times 4.
Okay.
10 ln.
Maybe we better start with 10 ln. Now, different calculators are going to do this different ways. Some calculators, it won't matter whether you go 4 times 10 ln. You don't want to end up with 40 ln. You don't want the ln of 40, do you? So, let me start over. Let's see if I want to make sure I get everybody with the best possible outcome for your calculator. Let's start with what? 10, and take the ln of that number. 10, and we'll take the ln of 10, and then times 4. Times 4. Now we got a number in the calculator, and we need to do equals. Okay, equals. To get that value, you probably don't need equals. Okay, and then we'll do plus.
And then in parentheses.
Well, I don't think you'll need parentheses there. I think you can just do 7, and then take the ln of it,
Times 5.
and then times 5, and then equals.
Equals 18.9398911.
18 points. So we got, for a numerator value, that's going to be 18.9398911. 9,4. Okay? All right? Now then, we're going to have to do the denominator, but the denominator you need to say, now divided by, do a divided by, that's going to get you the denominator, and then open parentheses, because we have to divide by this whole quantity. Okay? Now let's start with 7 ln, all right, times 2, and then minus 10 ln, and then if you just go equals, it'll give you the answer. But probably you'd want to close the parentheses, and then say equals. And I hope that gives you the right answer. What'd you get for an answer? 11.92. Okay? 11.92. Okay? Good. Thank you. All right. Any questions on that? Okay? Now, part of this is just practicing with your calculator, with your particular calculator. Let me mention, the exam is not the place to practice with your calculator. Be sure you get that done before the exam. All right?